Okay, in the previous video, we have seen how to solve standard minimization problem by graphical approach. Now we are going to solve it using duality. Okay, the problem is actually solve the following linear programming by duality. Okay, this is a graphical approach that we have seen in the previous video. So solve the same problem by duality. Okay, so first of all, you might ask what is duality here? Why can't we solve the standard minimization problems by simplex method as you solve the standard maximization problem. This is maximize, and you notice standard maximization problem, all the constraints are actually less than or equal, and for standard minimization problem all the constraints are actually the other way, greater and equal. So why can't we solve it using simplex method? Okay, you see, if you use simplex method, okay, before we look at the duality, let's see why we cannot, why can't solve using simplex? If you use simplex method, then you need to write, z minus 20x1 minus 40x2 equal to 0. And then in the initial table, I haven't add in the constraint. In the initial table 0, and the first row, where the basic variable is actually z, and you notice you have the z column, the value is 1, x1, the value is negative 20, and then your x number 2, negative 40. Then if we got slack variable, let's say here, slack variable 1, 2, 3, sorry, S3, and then the right hand side, then you have the ratio. Okay, please take notes that for maximizations, maximization problem, first step, get the most negative column. The most negative column. So in this case, will be negative 40. Meaning get the most negative column from your objective function row. So in this case, will be negative 40. However, for minimization, problem, you need to get the most negative, the most the other round, the most positive. So you need to get the most positive column. So, but in this case, we fail to get it. We fail to get the most positive column. That's why we cannot proceed using simplex method as what we solve the standard maximization problem. That's why we use another technique which is so called as duality. In duality, initially the original problem, the linear programming, this one extra, minimize z equal to 20x1 plus 40x2, subject to the constraint 36x1 plus 6x2 greater than or equal to 108, 3x1 plus 12x2 greater than or equal to 36, 20x1 plus 10x2 greater than or equal to 100, where x1, x2 are greater than or equal to 0. This is a initial problem, is so called as a primal problem. And then from the primal problem, we form into a matrix. This is a minimizer. And then your first constraint, you put into the first row, put up the coefficient. Okay, this is a x1, x2. So 36x1 plus 6x2, right hand side is 108. Okay, this is actually greater equal, greater equal, greater equal. Okay, this is equal. Second constraint, put up second row. 3x1 plus 12x2 equal to 36. Okay, and then the third constraint put up into the third row. 20x1 plus 10x2 greater than equal to 100. Okay, the tricks, the objective function put into the last row. So this is 20x1 plus 40x2. This is actually the z. Okay, this is a primer problem. From the primer problem, you form the matrix. Okay, after that, okay, okay, continue. This is from your primer problem, the matrix that you, okay, that you form it. Later on, okay, you will notice this is greater equal, greater equal, greater equal. This is equal. Okay, after that, you transpose the matrix. Okay, minimize will become maximize, greater than equal will become less than an equal, less than an equal. Okay, this is equal. Okay, initially z, later on in the transpose, okay, after you transpose it, it become a new variable w. Okay, you transpose. How you transpose it? Take the first column, 36, 3, 20, 20. It become first row. Yeah, it become first row here. 36, 3, 20, 20. Second column, so 6, 6, 12, 10, 40. Second column become second row. Okay, the right hand side will become your objective function. 100, 0, 8, 36, 100. So this is W. Okay, after we transpose, so take note, minimize become maximize, great all the, okay, greater equal will become equal say equal, greater and equal become less than and equal, less than equal. Initially our decision variable is x1, x2. Okay, after you transpose, this is so-called dual problem. So this is the initial problem, is so-called primal problem. Okay, after you transpose it, okay, the decision variable x1, x2, it become a new, okay, decision variable. Let's denote as y1, y2, y3, because, okay, 4 row when you transpose will become 4 column. So you have extra, okay, one decision variable. Okay, y1, y2, y3. Okay, this is the right hand side. Okay, from the table, read back your dual problem. Okay, this is W. So maximize W equal to 108y1 plus the 36y2 plus 100y3. Yeah, the objective function, subject to the constraint 36y1 plus 3y2 plus 20y3 less than or equal to 20, the second objective constraint. Okay, sorry, the first constraint. This is the objective function, the first constraint. The second constraint read 6y1 plus 12y2 plus 10y3 less than or equal to 40, where y1, y2 must be greater and equal to 0. Okay, so initially we cannot directly minimize, okay, z equal to 20x1 plus 40x2 using simplex. Okay, after using the concept of duality, it will become standard maximization problem. Okay, standard maximization problem where we can easily solve it using simplex method, as you've seen in the last week, okay, lectures. Okay, so now from here we are going to solve, okay, the dual problem. Okay, dual problem. Okay, how do you solve? You see how you solve the dual problem? You solve your dual problems. Okay, so maximize. So we change. Okay, from dual problem we change to simplex. So okay, all the decision variable you have to bring to left hand side. That's why, okay, in simplex, okay, methods, okay, your, okay, dual problem will become maximize W minus, all because our decision variable bring to the left side. Okay, W minus 108y1 minus 36y2 minus 100y3 equal to 0. Okay, and then they have got two constraints. The constraint is less than or equal. Okay, in the last week lecture, we said to make it equal, we plus slack variable 1. Then less than or equal become equal. Okay, and then plus S2. Okay, in the dual problem now, the S1 is actually associated with the decision variable X1. S2 is actually associated with the decision variable X2 in the primer problems. Okay, so now we are going to solve this using simplex method. Okay, we'll show you in Microsoft Excel. Okay, so maximize W minus 108y1 minus 36y2 minus 100y3 equal to 0. The first constraint, 36y1 plus 32y2 plus 20y3. Okay, if normal case standard maximization problem, we plus S1. Now in dual problem, the S1 is associated with the first decision variable in primer problem. So plus X1. So in the second constraint, normal we put plus the second slack variable S2. In dual problem, the slack S2 is associated with the second decision variable X2 in primer problem. Okay, so now we are going to put into the table 0. Okay, table 0. Okay, we have the basics variable, and then we got the W. Okay, then Y1, Y2. Okay, Y1, Y2, Y3. Okay, and then X1, X2, right hand side ratio. Okay, so from objective function, W is 1, Y1 is negative 108, Y2 is negative 36, Y3 is negative 100, X1 is 0, X2 is 0, right hand side is 0. Okay, going to total, we got 3 constraints. Okay, and then the first constraint, W0, 36y1, 32y2, 20y3, 1x1, no 0x2, right hand side is 20. Second constraint, 6 W is 0. You got 6y1, 12y2, 10y3. Okay, 0x1, 1x2 equal to 40. Okay, please check before you proceed. So okay, and then basic variable is a variable contain only one non-zero one non-zero entry, so which is W in the first row. Okay, Y1 is non-basics, Y2 is non-basics, Y3 is non-basics, X1, okay, second row contain one non-zero entry, so X1 is basic variable in second row, X2 is non-basic at the third row. Okay, so this is X2. Okay, and then for standard maximization problem, you get the most negative column from objective function. Okay, so this is a pivot column. Okay, I mean right here maximizations, maximization problem. Okay, make sure you get the maximization problem, get the most, the most negative column. Okay, the most negative column. Okay, the most negative column give you the pivot column. Okay, ratio is actually the right hand side divided by pivot column. So find the ratio, start from the constraint only. So it's the right hand side divide by pivot column. Okay, the smallest positive ratio give pivot row. Yeah. the smallest positive ratio give pivot row. Okay, intersection of pivot row and pivot column give pivot cell. So this is a pivot cell. Pivot column intersect with pivot row, you get pivot cell. Okay, identify until you get the pivot cell, then you can copy it down the table. Okay, this is a table 1. Table 1. Then you may remove the shading. Sorry. So in the new table, you have to make the pivot cell become one unit. So this is a R2. Okay, make it become one unit. You divide the whole row 2 by 36. The whole row 2. Okay, so you select the new row 2 here. Put it equal to the previous, the old row 2. Don't include the right hand. No need to calculate. Okay, I got wrong formula. I should include the right hand side. Select the new row 2. Type it equal to the old row 2. Divide by 36. Control and then press Control Shift Enter. Okay, if you cannot select the whole row, what you need to do is actually you can do cell by cell. So this divide 36. Okay, and then you copy. You copy left and copy to the right. Means actually 36 divide by 36 1. 32 divide by 36. You can see the formula. Yeah. This one divide by 36 and so on. Yeah. This cell divide by 36. Then you see this one F9 divide by 36. Okay. If you cannot, okay, mean the shortcut to copy, point to the right bottom, get the little plus, you drag it. That's shortcut to copy. If you cannot drag, you Control C, Control V, Control V, Control V, Control V, Control V, then move to here, Control V. Okay, but I will normally prefer equal the all pivot row divide 36, mean the whole row divide by 36. Okay. Okay, after that, you need to make the cell below and on top of the pivot cell become 0. Okay, need to make this cell become 0, this cell becomes 0 by using suitable row operation. So the new row 1, okay, the operation is actually you take the previous row 1, okay, negative 10x. So you need to plus 108 time of the new pivot row. New pivot row, I denote R2 prime. Mean R1, okay, is a O row 1 plus 108 R2 prime. This one, the new, okay, mean R2 prime is actually R2 from table 1. Okay. Then what I need to do equal to the you are making changes on row 1. So the new row 1 will be equal to the old row 1. Okay, if the value is negative 108, then you plus 108 time the new pivot row. New pivot row is the second row. Okay, so you see the formula. B8H8 is actually the old row 1 plus 108, because here negative 108, then you plus 108 time B5H15 is actually new pivot row. New pivot row. Then Control Shift Enter. Okay. So later on, we are going to reduce this 6 becomes 0. Similarly, okay, you want to make changes on new R3, then you take the old R3. Okay, if positive 6, then you minus 6. Okay, you cannot minus 6 only. You said 6 minus 6 is 0, but you have to do to the whole row, the row operation. So you must time with always, okay, the operation, you see, you are going to make changes on row 3 is always row 3. So plus minus how many times of new pivot row. So these are 2 prime. Okay, so then you select the new row 3 equal, the new row 3 is always equal to the old row 3. Okay, plus 6, so in minus 6 times the new pivot row here. So you see, B10, H10 is a old row 3 plus 6, then you minus 6 times of new pivot row. Then Control Shift Enter. So after we pivot at Y1, we notice Y1 go in as basics variable. Okay. And then you notice you still have the negative column in Y3. That's why, okay, Y3 now become pivot column. Okay, Y3 now become pivot column. Okay, because you still got negative column in objective function. Then we need to repeat the process until there's no more negative column in objective function. Then the solution is optimal. Since Y3 still is negative 40, so Y3 is a pivot column. Then you need to find the ratio again. Will be right hand side divide by pivot column. Oh, sorry. Don't find ratio. Correct. Almost confused. Okay. And then the smallest positive ratio now is 1, which give you your pivot row. So again, we still pivot at row 2. So after you reduce, make the pivot cell 1, make the cell on top and below pivot cell 0, Y3 will go in basics. Then Y1 leaving back to non-basics. Okay, the intersection of pivot column and pivot row give the pivot cell. So stop until you get pivot cell. Then you can copy. Okay, this time because table 1 contain all formula, so if you paste normal, all the formula which the row number will change it accordingly. Paste for you to see. See, running, because the formula run the row accordingly. Okay, then what you need to do is actually, okay, we have to, when you, from table 1 you copy and then paste value, paste value, so the, it's only contain value, no, no formula. Okay, now change to table 2. Okay, so remove that yellow, fill in color. So repeat the process, make the pivot cell become 1 unit. Okay, so the formula is the R2 from first table, which is R2 prime. So divide, if you divide, let's say by 0.5, see what happened. Okay, I'll show you. Let's say you divide by 0.5, then equal to, the new row 2 depend on the row 2 from table 1. So where I denote, when you see R2 prime in R2 from first table. Okay, if it, let's say, divide by 0.5, Control Shift Enter, you see, you won't get 1 exactly. You won't get 1 exactly. So to avoid this kind of problem, if we have the non-stop decimal place, what we need to do is actually equal this thing. Then I divide by the pivot cell value. Control Shift Enter. Okay. So that's why I will take notes here. The R2 prime divide by this value, which is E15. E15 in my case. Okay. And then please be careful. If you're not using the whole row, let's say you just do at this cell, and then you take this one, you divide by this cell, then you copy. Let's see what happened. Because we actually want the whole row to divide by 0.5556. If you do the formula one by one, because you divide E15, okay, you take E15 divided by E15. When you copy the formula, it becomes F15 divided by F15. So all the answer you will get wrong. You will get wrong. Okay. So if you want to key it, if you want to copy paste the formula one by one, then when you divide, okay, by this one which is constant, okay, okay, then you may put like this, or fixed column, just fixed column. And see now correct. And you see, it's the F15 always divided by E15. Okay, okay. If you put $2, okay, dollar E mean, okay, when you copy it, okay, E15, you copy the next column, E become F, but I fix at E. So still divide by E15. Okay, if I put dollar at the back, okay, mean fix the row. So when you copy it down, it is always divide by the cell E15. Okay, so will be easier, I think. Yeah, let's see this cell. No. Okay, this. Okay, I actually want this one. See. This cell divide by E15. Okay, or else, okay, I will prefer normally. Okay, I want to make pivot cell become one unit. So the pivot cell is row 2. So take the previous row 2 from the latest table, divide by this one. Control Shift Enter. This will be the easiest. Okay. This normally is the easiest. Okay. After that, make the cell on top and below pivot cell become 0. So this is R1. You want to make changes on new R1. Okay, row 1. So the new row 1 from table 2 depend on R1 from table 1. So that's why I put R1 prime. So the value is negative 40, then you plus 40 times, okay, on of the new pivot row, which is row 2. Okay, R2, table 2, I put double prime. Okay, so mean take R1 from table 1 plus 40 times R2 prime is actually our new pivot row. Okay, so select your new, okay, row 1 equal. New row 1 is always equal to the previous row 1. So negative 40, and then I need to plus 40 times of the new pivot row. Control Shift Enter. I get 0 already. Okay, then this value again is 6.66667. Okay, so you take the R3 from first table. If you minus, let's say 6.7 of the R2 double prime, okay, first of all, I show you, okay, if you take like this, R3 depend on the new OR3, okay, if you minus, let's say 6.7 time of the new pivot row, you see what happened. Control Shift Enter. You see, it wouldn't get exactly 0. Exactly 0. Okay, so to avoid this thing, okay, what we are going to do is we take the previous row 3 minus this cell time the new pivot row. Okay, and then if you want to copy the, if you do cell by cell, make sure you fix column. Put dollar in front of the E so that when you copy it, it remain, okay, by this cell, this column E. Okay. I think got something wrong. Let me check where is the mistake. Okay, there's a mistake here in the previous slide, I think. Here. This is 3y2. 3y2. So that's why 3y2. So 3y2. So this is 3. Okay. Because just now this is 3. 3. I get it. Negative 27. Okay. So now check it. Oh. Okay. Right. So now, okay, after table 2, we still have the negative column. So we still need to repeat the process. Okay, so now the pivot column, okay, is a y2, and okay, in table, okay, table 2, y3 now become basic variable. So y1 leaving. So y2 now become, okay, basics. So calculate the ratio again, will be right hand side. Oh, here what, not a variable. Okay, hold on. Right hand side divide by, sorry. Okay, right hand side divide by pivot column. Okay, here what happened? Okay, never mind. Okay, never mind this one. Okay, do it again. This one is the R1 from the first table. Okay, plus 40 times the new pivot row, which is second row in table 2. Okay, 100. Okay. Then now we still got the negative, okay, negative column. So this is a y2 now become pivot column. We calculate ratio again, which is right hand side divide by pivot column. Okay, the smallest positive ratio now is the last row. So the last row now become pivot row. Okay, y3 already go in basics. So the intersection of pivot column and pivot row, which is a 10.5. 10.5 now is a pivot cell. Okay, so after obtain the pivot cell, copy and then paste value. So this is table 3. Table 3. Yeah? Okay, and then you can back, okay, a frame, center it. So 10.5, we want to make it become 1 unit. Pivot cell have to make it become 1 unit. So it's a R3 from second table divide by 10.5. Okay, so select the new, okay, third row equal to the previous third row divide by, okay, I want to divide 10.5. Control Shift Enter. Okay, and this is a cell. Then we need to make the cell on top of the pivot cell become 1 unit. So this is a R1 from second table. Mean the R1, okay, on the new table 3 depend on R1 from second table. So negative 21, I need plus 21, okay, of the new pivot row, which is R3 double prime. Okay, so we select the new row 1 equal to the old row 1. So minus 21, so plus 21 time of the new pivot row. Control Shift Enter. Okay, and then the second row, so R2 depend on the R2 from second table. So 0.15, so minus 0.15 of the new pivot row, which is a R3 double prime, stand from R3 from second table. So the second row equal to, okay, the second row in the table 2. So 0.15, so minus 0.15 time of the new pivot row. Control Shift Enter. Okay. So you can observe that there's no more negative value in objective function, hence the solution is optimal. Since there is no more negative uh, value in objective functions rho, thus the solution is optimal. Okay, okay, and then just now you pivot at here, y2, then y2 become basic variable. Okay, and you can read the solution basic variable, let it equal to right hand side, right hand side. Okay, and then the x1 you can read the value from here, x1 equal to 4, x2 equal to 2. Okay, and then mean the primer problem content of the z. Okay, at the end of your dual problem, w is actually equal to z, so equal to 160. And then x1 is to read here, x1 equal to 4, x2 equal to 2. Okay, in the primer problem solutions. Okay, and then the dual problem solution, where you can read it from here, y3 equal to, right hand side is 0.57, and then y2 from the right hand side is 2.86. y3 equal to y3 equal to 6.67. Sorry, there's a ratio. Y3 here, y3 equal to 0.57, y2 equal to 2.86. Okay, y1 is non-basic, so y1 equal to 0, as what we said. Okay, y3 equal to 0.57, y2 equal to 2.86. Okay, y1 non-basics equal to 0. Okay, but don't say x1 you cannot let it 0, x2 cannot 0. Okay, because from the dual problem at the end we can obtain w is actually equal to z. Okay, and then dual problem, sorry, you got w equal 160. W equal 160. Y3 equal to the right hand side 0.57. Y2 equal right hand side 2.86. Okay, y1 because it's non-basics variable, we let it equal to 0. Okay, x1, x2, okay, is actually the decision variable from primer problem, where we read it from the first row. X1 is 4, x2 is 2. Okay, where it's actually tally back with what we obtained, okay, in the previous K video using the graphical approach. X1 is 4, x2 is 2. Okay, your Z is 160. Z is 160 here. Okay, so this is using the duality. Okay, I repeat back the duality. In the initial problem, minimizations, okay, we cannot solve it using the simplex method. Okay, simplex method, because we couldn't find the most positive column for minimization problem, because when you bring, okay, 20x1 40x2 to left hand side, this become minus 20x1 minus 40x2. We couldn't find the most positive column for standard minimization problem. That's why we cannot proceed it using simplex method. Okay, however, by using duality, okay, mean the initial problem is what we call primer problem. You put into the matrix form, where first row must be constraint 1, followed by constraint 2, constraint 3. The last row is the objective function. So minimization problem, okay, after you transpose it, it will become dual problem, where minimize will become maximize, okay, and then you see if you transpose first column become first row, so this will become the constraint, and decision variable x1 x2, after you okay transpose it, it become a new decision variable y1 y2 y3 right hand side. So the z, okay, will become w. Minimization will become maximization. Minimization, okay, initially all okay are greater and equal. In the maximization, it become less than and equal. Okay, and then the trick is only when you solve the dual problem, okay, the less than or equal, the slack variable is actually associated with x1, which is a okay first decision variable. S2 is actually the x2, the second decision variable. Then you solve like you solve the okay standard maximization problem. First step, okay, you just okay put it into table 0, table 1, and then you identify pivot column, which is the most negative column. Ratio is a right hand side divided by pivot column. The smallest positive ratio give the pivot row. Intersection of pivot column and pivot row give the pivot cell. Then you copy it down, make it become new table. Okay, in the new table, you have to make the pivot cell become one unit, make the cell on top and below pivot cell become 0, so that the pivot column variable will go in as basics. Okay, after that, if there's still any okay negative column, then you repeat the process. Okay, finding the okay pivot column, pivot row, pivot cell, until pivot cell you copy it. Okay, copy it to make a new table. Okay, in the new table, okay, this is table 1, so you have to make this cell become one unit. Okay, and then make the cell below and on top of the pivot cell become 0 using suitable row operation. Repeat the process until no more negative column. Then the solution is optimal. One is optimal, you read it, okay, here the basic variable w actually equal to z equal to 160, y3 equal to okay the right hand side value, y2 is here, so y1 non-basic equal to 0. This is a okay dual problem. Primal problem, w equal to z equal 160, x1 is 4, x2 is 2, which is tally with the solution obtained using graphical approach. Okay, okay, so we'll stop here, and in the next video we are going to see okay how we can solve this standard minimization problem using okay using the Microsoft Excel